So students, today we have a class, chapter solid state, that we are continuing for last 2 to 4 days. The topic for today is imperfections in solids or defects. You have been posted videos on Edupose and you have seen the videos on the various type of defects which are possible in case of ionic solids and metallic solids as well. So today you will be presenting the topic in the class. There are total 5 major defects or imperfection types which are there in metallic solids and ionic solids. The class has been divided into 5 groups. So each group will be given a particular type of imperfection or solid. You discuss it amongst your group. I am giving you a 2D representation of the imperfection of one type. Total there are 5 different types which broadly we have seen in the videos. So each group is going to discuss the kind of imperfection that the group gets allotted, and then one of you, either the group leader or the group representative, would come and discuss the type of impurity that they observe in the 2D representation that has been allotted to them, right? But before that, did you really enjoy seeing the videos?
Yes, ma'am.
A louder answer.
Yes, ma'am.
Yes. Were you able to visualize the defect better through the video?
Yes, ma'am.
That gave you a 3D representation, right?
Yes,
okay, let us see how much you have understood, how much you have gained in terms of conceptual clarity. So I will invite group 1. Please come and collect your handout or the 2D representation that you need to explain. Group 2. Group 2, there are 2 representations for you because they fall under the same category and need to be discussed together. Just take out some time to discuss it in your group, and then one of you can present the type of imperfection. Coming here on the display board, you will pin up the 2D representation and explain about it. Group 3, Group 4 and Group 5. Not more than 5 minutes by my watch, children, right? So 5 minutes, and after 5 minutes Group 1 will come and make the presentation. Start.
Good afternoon. My name is Bhavya Gola and I am the representative of Group 1. The topic that I have got is impurity defect, and I would like to explain it to you with the help of an example of sodium chloride. In molten sodium chloride containing a little amount of strontium chloride, strontium ion having a charge of +2 replaces 2 sodium ions having a charge of +1 each. Basically, we want the total charge of the lattice to be neutral. Therefore, one strontium ion takes place of one sodium ion, that is here, while the other place of sodium ion that has been replaced remains vacant. So, there is one vacancy in the lattice while one place is occupied by the strontium ion. The other examples are silver chloride and cadmium chloride. Thank you.
Good afternoon. I am Akshata Goel, group representative of Group 2. Today I will tell you about Frenkel defect and Schottky defect. Frenkel defect. It is seen in ionic solids where the size between the anion and cation is very large. Cation, being smaller in size, dislocates from its normal site to the interstitial site, creating a vacancy defect at its original position and an interstitial defect at its new location. It is seen in CSCl. There are 3 consequences. First, density. Density remains constant as the mass of the solid remains constant. Second, dielectric constant. We know that dielectric constant is dependent upon dipole moment. Dipole moment is equal to charge into length. We can see that charge at a particular area increases, therefore the dielectric constant increases. Third, electrical conductivity. Electrical conductivity increases because of the movement of free ions in the due to the vacancies. Frenkel defect is also known as dislocation defect. Now, Schottky defect. Schottky defect is seen in ionic solids where the size between the cation and anion is similar. It is seen in NaCl. In Schottky defect, the equal number of electrons are missing from their lattice points and create vacancies to maintain the electrical neutrality. There are 3 consequences. Again, first, density. Density of the solid decreases.
Good afternoon. I am David and I am a representative of Group 4. Today we are learning about different types of impurities and defects in solids. My topic is metal access defect due to anionic vacancies. A common example of this is NaCl crystal. When NaCl crystal is heated in the presence of sodium vapors, sodium ions are released with release of some electrons. Here, in the sodium crystal, we already have some chloride ions. So these chloride ions go up and they combine with Na plus to form another NaCl crystal. The electrons the electrons move to the vacancy. This vacancy is called an anionic vacancy, and electrons get trapped in it. The electrons trapped in it are also known as F centers or Farb centers, because these electrons impart color to the flame of color to the NaCl crystal. A golden yellow color is emitted by the crystal. So these defects which occur due to an anionic vacancy in the solids are called metal excess defect due to anionic vacancies. Thank you.
Good afternoon. I'm Sahil Khanna and I am here to represent Group 5. We have got the topic metal excess defect due to extra cation. In this example, we'll take ZNO. ZNO is white at room temperature, but when we heat it up, it liberates oxygen and it turns yellow in color. The excess Zn2 plus ion and the electrons occupy the interstitial sites in the lattice. As you can see, this and this are here. The electron imparts yellow color to the lattice, and due to this phenomenon, as these occupy interstitial sites, this is known as metal excess defect due to extra cation. Thank you.
Okay, students, thank you so much to all the group representatives for giving beautiful presentations, and most of them were conceptually correct. However, let me test how much of the concept is clear to you after these presentations and videos. So there is a worksheet for you. It has some questions. You'll be given 15 minutes and you will try to finish the worksheet, after which we will discuss the worksheet in the next period. Also, you will have the post on your Eduposer platform today as well on the next topic. So you all are supposed to look into the videos and come prepared tomorrow for the next session on flipped classroom under the chapter Solid State, class 12th chemistry. Equation 2. What should be the next step? 1 is equal to 2. Now rest you will do on your own. Equate 1 and 2. Total positive charge is equal to total negative charge. From there, find out the value of x. I am not going to solve it. 94. So you are going to solve it. 94. 94. One group is left. Give it one group. You are getting 94 mathematically. So x is equal to 94 with the number of nickel plus 3 ions. How 4? 98 minus 4. Very good. So this is equal to 4. Now what is the fraction? Very good. And if I say fraction percent, then into 100. Very good. So fraction percent of nickel 2 plus ions will be 94 by 98 into 100, and hence the fraction percentage of nickel plus 3 ions will be how much? Either you do 4 by 98 into 100, or you can simply subtract what you get here from 100 to get the second answer. So what is the final answer? In terms of percentage, 95%, 95.6. One group is getting 95.6, the other is also getting 95.6. Check your calculations. So let's slight variation in the answer. 95.2. Okay. So 95.2 for this, and this you can get by subtracting 95.2 from 100. So you wind up here, because the bell is going to be rung immediately. Departure time is there. Please keep your worksheets. Now you have solved them. These are to be pasted in the homework copy. You will get your homework copies tomorrow. And today, there are going to be 2 more polls on Educosite based on what you have done today. So answer the polls and look at the videos. Come prepared for tomorrow. We would wind up this chapter by 12. Okay? Thank you.